Hey professor, this is the lab demo or lab video for lab 5. Um, Real quick, I just want to go over the code and the changes we made. So the biggest stuff happens in reg file, so I'll go over that. So the first thing, our assignment was to have the write data be double the size of the read data. And so as you can see here, we have data width times 2. And so in our write data, we are getting a total of 16 bits, while in our read data, we are getting a total of 8. To account for the 16 bits, we have declared two different memory logic signals, and then we have assigned, I guess, those signals to the lower and upper 8 bits each. And then in order to account for that in our read operation, we created this signal called, where is it? Read control, or R control. And so R control allows us to bring in both sets of the 8-bit data and have them being read when read data is called, or the command is activated maybe. Really quick for the test bench, I did do this in binary. The rest are in decimal just because that's easier to write, but I wanted to do this in binary just so I could make a really nice, easy number to look at. So I have this right here, and we'll see that in the test bench, and that we can see that this 1 gets pushed into the upper 8 bits. So now coming over to our test bench, let me scroll it back. There we go. So we can see that we do run that half cycle at empty or at 0. And then we load in a 5, just like you did. And by the way, our test bench, in terms of the write and read commands, they run the exact same as yours. And it was just nice because they counted for us properly. And so all we had to do is just make sure that the full and empty signals were still triggering at the same time. So it was just an easier way to gauge that our progress was, working properly. But what we can see here is that we have 385. And so when we look at our two sets of 8 bits here, we do see that the upper 8 bits does take on a 1 from that 385, and then the lower 8 bits takes on 129, and so that's how it reads it when it's split up. And so it's cool to see that, and good to know that both memories are working accordingly to break up that 385 number that we've written in. And then the rest works just about the same. Oh, and as you can see here, our data is reading both sets. And so you can see that we're putting in a 5, and so it reads a 0 for the upper and then puts a 5 in for the lower, reads a 0, puts it in, and then as you can see, when we read for the 385 right here, we see that we get the upper 1 and then the lower 129, and so on and so forth. And so moving a little bit farther down the test bench here, we see that everything gets written in, and then we start reading it, so we can see the full value right here of what's being read. And as we can see now that everything has been read, or I guess we see it as full, we switch to reading now because we see our full trigger. And then once we finish reading it all, we get our empty trigger. And then we also follow along for the simultaneous write and read functions to close out the test bench. I added 16 in there because I thought it would be fun. It's just a bigger number, better than the single digit ones, but it makes no difference. But anyways, that is our video demo showing that we do have the double write over the 8-bit read data, and that it is working properly, and the rest of the test bench proves that. So thank you.